So let's do this question. So coin change. You're given an integer array of coins, and you want to find the minimum number of coins to use to make up a target number. In this case, we have 11. So the minimum number of coins here to use, we can use any number of these coins, so any multiple of these coins to make up this number. So we get 2 of these ones and 1 of these ones to get 11. So it'll be 3, so the answer will be 3. This is a classic DP problem. So with DP, you try to figure out a subproblem. And then a transition. How can you find other values using the subproblem, like greater values? And then you want to figure out a base case. To figure out a subproblem, you can try different possible subproblems and see what works. That's usually how it goes. But the subproblems, if you want to find a subproblem, it's usually based on the amount. So if we want to find different amounts, then that will be the subproblem. So that dpi, where I is the amount, equals the min number of coins. So basically the answer to get I. Right, so let's see if that works. Transition. So how would we get let's say for any arbitrary I, let's say we already know all the subproblems for numbers less than I, then we could probably say that this is equal to 1 plus the minimum. Why 1 plus? So just assuming that so let me start again. 1 plus the minimum of dp of I minus c. Alright, for all c in coins. That kind of makes sense, right? What's the minimum number of coins to get, for example, in this case here, if I know that if I want to find dp of 6, that will be equal to 1 plus, so 1 coin plus the minimum number, so basically the answer to get 6 minus 1, which is 5. 6 minus 2, which is 4. And dp of 6 minus 5. Dp of 6 minus 5, which is 1. So out of all these, if I get the minimum answer for all of these, and then just add 1 to that, I can get 6. And I know that will be the minimum answer. So that's basically the whole problem. Okay, what's the base case though? Well, if we know that we want amount 0, we need 0 coins. And it's actually really very neat that if I want to find coins such as 5, dp of 5 would be equal to 1 plus the min of either dp of 0, dp of 5 minus 1, which is 4, dp of 5 minus 2, which is 3, and dp of 5 minus 5, which is 0. And the dp of 0 is going to be 0, so the min answer here is going to be equal to 1. And that makes sense, because to get amount of 5 out of these coins, we could just use the 5 coin, and that's the minimum. Okay, let's implement this. So we can have a DP array of size amount plus 1. It's uninitialized initially, so we need to have 0 is equal to 0. That's the base case. Then we'll go through each of the coins, starting from 1 all the way up to amount. Then we want to find the answer for dpi. The minimum answer, we could set it to be equal to int max initially, so that when I compare it dpi to a minimum another value, initially it'll be set to the best value so far. So we could say, so we could go through all the coins. If the current amount minus the coin value is greater than 0, greater than or equal to 0, and the dp value of I minus c, if we can actually find the subproblem that's greater than or equal to 0, then we want to consider this as an answer. So you can say dp of I is equal to the min of itself and 1 plus dp of I minus c. At the end, dpi could still be int max. So we want to set it to -1 if it is. If dp of I is equal to int max, then set dp of I equal to -1. Then at the end, we want to return dp of the amount. So give that a go, give the base cases a run through. This is 0. Okay, see if that works. Awesome.